Okay, good afternoon, everybody. I'm sorry about the slight delay in starting. We had a couple of technical issues, hopefully now resolved. So we'll continue as intended, and I'll go through today's webinar. So, hello and welcome to our second webinar in our series, introducing our Atlas product and highlighting its innovative features and use cases. I'm Paul Williams. I'm one of the product managers here at Enable My Team, and during this webinar I'll be taking you through a variety of features that we have developed for some of our rail clients. Before I dive in, I just want to mention this webinar is being recorded and will be made available on our LinkedIn page for future reference. I'll aim to be presenting for around 15 to 20 minutes, allowing time for me to address any questions afterwards. Therefore, if you do have any questions during the webinar, feel free to drop them into the chat and I'll pick them up afterwards and provide answers where I can. So firstly, for the benefit of those who may not already know who we are, Enable My Team are an engineering technology company. We work directly with clients, some of which are shown here, to provide innovative solutions to problems posed to us or problems that are encountered upon their infrastructure projects. The solutions we have developed so far are what we have now incorporated into our Atlas product, and we'll continue to do so as we develop further features in the future. With Atlas being available to projects of any size now and not just the very large, its benefits can now be brought to the entire or the wider industry as a whole. Atlas has a strong focus on its interoperability, with all the data being held within the platform being accessible through our open APIs. Making the data available in this way allows Atlas to be better deployed on projects and integrate with their existing applications and processes. We have an online knowledge hub that also provides details and guidance on how to use our APIs, as well as guidance on the other features available through the Atlas UI itself. And as Atlas acts as a federation platform, it has great versatility in its integrations with other applications and data from various sources and in different formats. With this flexibility, it forms a common data environment that can provide added value to projects by allowing more to be done with the project data. Within the rail sector specifically, ASIC can build network models, store data for assets, provide useful insights from survey data, and ties in with maintenance systems where necessary to enable lifecycle management. And above all, Atlas is a web-based SaaS platform optimized for collaboration and concurrent working, and removes the need for specialist software or powerful workstations, and can utilize enterprise integrations, making information accessible to everybody on the project through the cloud. Through providing democratized digital twins using survey, design, and real-time data, Atlas enables strategic decision-making and analytics to make rail maintenance safer, faster, and cheaper. As well as being able to store an array of different data sets, Atlas has a built-in GIS interface to display data and allow it to be navigated as required. Within the viewer, different data sets can be overlaid, turned on and off as required to enable full comparison options. And understanding that projects increasingly work with ever-growing data sets, expecting humans to manually process and utilize all this data is not a realistic option. And this is where AI comes into play. Within Atlas, we provide multiple techniques to process and provide value from project data. And that's what we're going to run through today. So Beginning with point cloud feature extraction. Feature extraction is the ability to identify, classify, and extract physical features from data. Specifically for Atlas, this relates to extracting features from visual data formats such as LiDAR and video. Where such data sets are geographically referenced, it allows for accurate extraction of feature positions and geometry, meaning they can be used in combination with other data such as design models and to carry out comparison and analysis. Atlas already supports the use of a variety of formats used in LiDAR and drone data capture, with us having worked with a number of data capture providers already. And regardless of the source format, to provide features offered by Atlas, captured data is processed into the platform itself, allowing all features to be used consistently. One of the key features Atlas is able to extract is the track center lines. Knowing these provides a foundation for other feature extraction and analysis. Through implementing our machine learning techniques, our trained algorithms provide the automated identification of rail track assets from within point cloud data. And beyond this, the positions of the rails are used to determine the track center lines. This centerline data is captured as a separate assets within Atlas and is related back to the track assets. And as mentioned earlier, regarding data availability through Atlas's open APIs, this includes the centerline data generated, and therefore, if required, it can be used for other purposes and evaluation within systems outside of Atlas. Another feature we can identify are point toes and their position along a track. And this is building on the extraction of the track centerline data. We can subsequently use this to determine the positions of point toes. The simple methodology being that where the centerlines meet or overlap indicates the location of a set of points. Beyond their extraction, points can be created within Atlas, and subsequently, as we can see here, 3D geometry can be placed within the GIS map to make the assets visible alongside other data sets, such as the point clouds or other 3D models. Similarly, on a 2D level, icons can equally be placed in the 2D map layers, so we know where the assets exist. And again, the data generated is all available through the APIs to extend its potential beyond Atlas itself. In addition to track assets, other physical assets along the rail corridor can also be extracted. Assets such as signals and their associated structures, fixed structures including bridges, tunnels and platforms, and even vegetation. Building on the use of AI to automatically classify features from within a point cloud, after their initial identification, they can be extracted and created as new assets or linked to existing assets within Atlas. Once assets have been classified and created, further options become available in terms of analysis. For example, in terms of vegetation, data being analysed from a recent survey may indicate that areas of vegetation are close to the permitted safe distance from a track. Therefore, a maintenance activity could be planned to address this before the vegetation becomes a hazard. And here we can see some examples of the different features that have been classified and extracted being toggled on and off within the platform. For fixed structures, as mentioned, after classification and extraction, the assets can be used for more critical analysis, such as gauging. As an example, the edge profile of a platform can be identified to gain an accurate position for measurement purposes and can form part of an SEO file output from Atlas. And Atlas is also able to directly interface with other gauging tools to enable further analysis outside of the platform. After isolation, section views of assets can be created. Here we've just seen a tunnel being identified and then the cross-sectional view. And as per all the examples, the extracted features have different color styles applied, And this last shot shows an example of the underbridge of on the rail network being highlighted in orange. Moving on to overhead line equipment, which is another key asset within the rail corridor and is understandably one that carries a strong focus on operation and maintenance. Atlas can extract overhead line equipment component assets from the survey data with accurate positioning, which is beneficial in allowing further computational analysis. An example being measuring the stagger of the contact wire along the section of network. Again, new assets can be generated from the extracted features, and these can be related within Atlas accordingly to how they're installed, so that dependencies can be identified if maintenance is required. As well as Atlas being able to classify a number of asset types already, we are continuously training our algorithms on new data so that more assets can be captured. We don't just rely on our own training. Atlas allows users to manually isolate features from within capture data, specifically in asset classification, and feed this back into the system. This means users can both speed up the identification of assets they may be interested in, but also enhance the classifications offered by Atlas itself. As we're seeing here, a mast is being isolated within the point cloud data, ready for classification and feeding into our AI training loop. Now we'll take a look at another area, which is object recognition through the use of video data. So video data provides another means through which we can identify and extract features from within the rail corridor. Using forward-facing video captured from train-mounted cameras, Atlas's AI can identify multiple assets within the rail corridor. This type of capture is ideal for undertaking asset audits, covering a large stretch of network without requiring the placement of engineers in the field, effectively turning such a task into a safer desktop exercise. Here we have another example specifically aimed at identifying signals and their specific type at high speed. If any anomalies are spotted or signals are missed due to the type not being covered by the machine learning, then corrections and additions can be fed back into the learning loop to further improve the accuracy of the AI algorithm. In another specific example, we have the capture of speed limit signage along the rail corridor, further enhancing its capture by using additional techniques to automatically identify the limits being displayed. On top of this, we can also identify the specific track each limit is associated with. Here we can see a pair of speed limit signs being identified, and OCR being used to detect the limit values displayed. And then to identify the associated track routes, we can fuse this with our track vision data, a topic we'll cover shortly. So far, we have seen how we are able to extract assets from within one data source or another. But what about if assets display visual information that can't be picked up directly from a single source? Well, this is where fusing data from different sources comes into play. In this example, we have identified and extracted a signal asset from point cloud data. In addition to the point cloud data, we also have processed forward-facing video for the same section of track. Geolocating the video so the frames are held at the correct location along the track. By doing this, we can view the same signal on the video feed, which provides additional visual data that the signal displays. By using OCR to capture this data, we can link it through to the record within Atlas and then tie this back to documentation related to the asset, such as the assessment records of a signal. And being able to do this builds upon the golden thread of data that is held within Atlas as a common data environment. And as briefly touched on previously, I'll now explain our track vision capabilities. we've developed a sophisticated method of obtaining highly accurate track centerline data through using train-mounted video capture. Recognizing that capturing assets using video and GPS alone is not always suitable and can result in assets being incorrectly positioned or associated with the wrong track, especially in highly congested areas. We have developed a track vision which computes the camera path using references within the frame. The calculated path is then associated to the known route to determine the correct track upon which the train is traveling. So in this example, you can see that as the train approaches the junction, it turns left. If we were to rely entirely on the GPS positioning, it would carry on or detect that it had gone straight on. But using our track vision, we're able to use the data held within Atlas to determine that it's taken the left turn. And this accuracy is crucial because it allows us to ensure that assets are associated to the correct tracks. Finally, onto a couple of other innovative features. Within Atlas, we can automatically convert video into 3D data, also known as photogrammetry, to generate and extract additional details. The generated point cloud data subsequently allows asset extraction to be undertaken, as well as taking measurements between points of interest. Using photogrammetry like this provides even more opportunity to gain insights from video data, whether that be validating designs against the as-built environment, proposed design models, or identifying proximities between existing assets or objects. Next, we have signal sighting, a more recent development that we've implemented, where we're able to determine the maximum clear path of vision between a signal and a train. But the concept can equally be applied to other scenarios and not just within rail, for example, road signage or emergency route signage within buildings. Here, having identified the signal for which we wish to assess the visibility, we select it as the target. Then we can provide the source location. In this example, we're uploading the linear coordinates of the track center line. And in addition, we're providing a height offset of 2.5 meters and as an approximation of the height of the driver's vision. After the calculations have been completed, the results are displayed, overlaid within the view. The maximum unobstructed line of sight is represented with a blue line, along with the source coordinates being color-coded, green for the unobstructed view and red for the obstructed view. Having this feature provides a quick and effective way to identify potential obstructions along the rail corridor, or to determine a maximum distance from which an object can be seen. A further advantage of being able to see the results within the view is that other data layers can be applied, such as satellite imagery or even 3D models of proposed construction, which can then form part of a more in-depth analysis when reviewing the results. So through our ongoing work with clients and POC projects, we continue to add to our Atlas roadmap and aim to provide even more beneficial features. So as well as these features driven by industry, we're also working on product developments that bring benefits to clients in other ways in terms of the product offering. So here we're listing some of our headline developments that we're working on currently. The integration of the application of the integration SDK. The aim of this is to simplify the integration with other direct capture providers. Drone and aerial scan AI, enhancing our AI capture of assets from these capture methods, and automated change detection. So this will be a beneficial feature that will compare data sets from 2 or more time periods to identify differences between them. And it's likely that when these are implemented that we'll include them in future webinars. So as we come to the end of the presentation today, I'd like to thank you all for joining, and I hope that what you have seen has been insightful in terms of what can be achieved from your data. If you'd like to find out more or have any further questions after the webinar, please get in contact. And if you're interested in using Atlas, we now offer a free tier, which is available through the QR code shown here or on our website, enablemyteam.com. Through this free tier, you'll be able to use most of the features explained today to get a feel for the platform. But if there are specific advanced features that you're interested in and want to discuss further, again, please get in contact and we'll be happy to do so. And we'll be continuing our webinar series, and here are some of the other topics that we'll be covering. If there is anything specific that's not listed, again, feel free to drop us a line and we'll aim to include it. And as you can see, our next webinar is due to cover point cloud commenting and collaboration. And that's due to be held on the 23rd of April, so in about a month's time. And we're now moving to the Q&A section. So if you do have any immediate questions, please feel free to drop them into the chat and I will answer what I can, or otherwise I'll provide a response after the webinar. I'll just wait a few minutes to see if any questions come in. Okay, like I said, if there are any questions you think of after the webinar, please feel free to drop us a line and we can answer them, or even have a more in-depth discussion of some of the features that we do offer. So again, I'd like to thank you for joining today, and we look forward to joining again in future webinars where you learn a lot more about Atlas and as we continue our journey of providing advanced features for various industries. Okay, thank you.